Hey guys, this is Ed Revolusi here, and today we'll be taking a look at the subtopic of heat capacity in chapter 4 form 4 physics SPM, which is heat. Okay, so we must get the definitions out of the way. Temperature is defined in high school level as the degree of hotness of an object, and SI unit is Kelvin, okay, represented by a K, capital K. And it's usually in these questions we are about to encounter, it's usually represented by degrees Celsius, which is the C. And the heat is defined as a form of energy, which is energy, so its unit is joule, represented by a capital J. Now to the main topic of today, which is heat capacity, which is represented usually by the letter C, a lowercase c. Okay? The equations that matter the most for this subtopic is this equation. It's very important. You also encounter it in chemistry. This equation is Q equals to mc theta. So Q stands for the heat energy consumed or released. M is the mass. We usually write it in kilograms or grams. Heat capacity, okay, the one we talked about just now, and temperature change. Temperature change is the final temperature minus the initial temperature. Okay, it's always positive in physics. Okay, in physics, when you're calculating this, we assume the reaction is exothermic, it releases heat, so it's always positive. Now, the definitions you need to know, other than the earlier two, which is specific heat capacity. Okay, the keyword here is very important, specific. When they tell specific, you need to mention 1 kilogram here. Okay, if you don't mention, it's wrong. But if they just ask you the definition of heat capacity, you can omit the 1 kilogram here. So the definition of specific heat capacity is the amount of heat energy needed to raise the temperature of 1 kilogram substance by 1 degree Celsius. Okay, 1 degree Celsius, very important. Without a change in state, this is not that important. Okay, the keywords are underlined in black. So, if a specific heat capacity of a substance, let's recall the definition now, you can recall it now, is higher, okay, if it's higher, you need more heat energy to heat up that particular substance to a certain temperature. Okay, if the specific heat capacity of the substance is lower compared to this substance that I'm kind of mentioning here, you need less heat energy to heat that substance up to the same temperature. Okay, we can see that here. I have two objects here, two cubes. They have the same mass and same initial temperature, which is 20 degrees Celsius. Okay, and I want to heat them up to 50 degrees Celsius. So the change in temperature will be 30 degrees Celsius. Okay, minus this and this. Okay, so I'm using a same power. Okay, I'm transferring the same amount of heat energy per second to both of this. Okay, so power is energy over time, so the rate of transfer of energy. So I'm transferring both, let's say I'm transferring 500 watts, which is 500 joules per second, to both of this. But this substance has a higher specific heat capacity, and this one has a lower specific heat capacity compared to this substance. So which one would take a longer time to reach 50 degrees Celsius? Well, we have to look up here again. So if the specific heat capacity of a substance is higher, more heat energy is needed. So technically, I'm putting the same amount of heat per second, the same amount of heat energy per second to both of these. So this one needs more heat energy to reach 50 degrees Celsius. So this substance with the higher specific heat capacity would take a longer time to reach 50 degrees Celsius, which is the final temperature that we fixed. Whereas the low specific heat capacity substance will take a shorter time to reach 50 degrees Celsius. But the story changes when I leave them to cool. Once they are both reached 50 degrees Celsius, when I leave them to cool back to 20 degrees Celsius, which is their initial temperature, this substance will retain heat better. Because it has more heat energy in it, because of its high specific heat capacity, it will stay hot longer, okay? Whereas this one with the low specific heat capacity that got hot very fast will lose heat fast also, because it has less heat energy in it compared to this one. So this is the basic understanding here. So if the heat capacity is high, an object takes a longer time to heat up to a certain temperature, but it can retain the heat better. Whereas if a substance has a lower specific heat capacity, it takes a shorter time to heat up, but it also takes a shorter time to lose that heat, as there's not that much heat compared to the higher specific heat capacity substance. So that's all for this subtopic. It basically revolves around this specific heat capacity. Okay. Thank you guys for watching, and stay tuned for more videos on this chapter. Feel free to suggest topics for future videos and also criticisms on the current videos. Thank you. Peace.